This required deep expertise and significant engineering effort. We've come a long, long way in a remarkably short period of time. Through our open source community collaboration and sustained investment in Rockom, our software stack, AMD Instinct GPUs are powering some of the most important and consequential workloads on the planet. But the biggest change is still ahead of us. AI is transforming how software is getting built, and we are bringing that transformation to Rockom. And that's what I'm excited to share with you guys today. Our software teams have been moving fast with relentless focus on developers. We've invested at every level of the stack in build and test infrastructure so we ship faster. Rockom releases now go out every 6 weeks, not every 4 months. We've continued to expand the work we do with our AI ecosystem partners. And the result? More features, faster performance, and a significantly better out-of-the-box experience. Our strategy that has gotten us here has been remarkably consistent. It's built on 2 core principles. Partner deeply with the open source ecosystem and build with the right layers of abstraction to enable developer productivity. Open source gives us velocity and scale, and abstraction makes developers more productive. Our deep, deep commitment to open source has resonated with the community that has truly embraced AMD. From frameworks and compiler stacks to inference engines and model hubs, AMD is now becoming part of default enablement for the most important AI communities, such as Hugging Face, PyTorch, JAX, VLLM, and SGLang. This is why new models get day 0 support, and why the world's most important AI workloads run on AMD today. That is a big shift. Inspired by engineers seeking productivity, abstractions have evolved to enable work at the right level of detail, hiding complexity when they want speed, and exposing control when they need performance. From low-level programming in assembly and C to block programming abstractions like Triton to Pythonic frameworks, we've invested in key abstractions. Aether, our kernel library, and Atom, our serving engine, get you peak performance without writing the kernels yourself. FlyDSL is a brand new Pythonic domain-specific language that gives you low-level control with the performance of hand-tuned C++. And Mori, our communications library, helps deliver leadership performance on the latest models like Minimax. But look, something very, very exciting is happening. Over the past year, I've seen something remarkable inside AMD. Our engineers are using AI models to generate GPU kernels, optimize code, debug issues, and improve performance. And in some cases, these AI-generated kernels are shockingly good, better than what we expected, sometimes better than the most manually tuned versions. The first time you see this, you're a little bit skeptical. You run more tests, you try to break it, you look for what went wrong, and then you realize this is real. What has happened in general software development is coming to significantly transform GPU programming. It's going to reduce the time it takes to bring up workloads, make optimization automated, and it will remove any remaining barriers to broad adoption. We want to put that capability in the hands of every developer. So today, I am excited to introduce Rockom.ai. It's an agentic AI platform that brings the capabilities of AI-assisted GPU programming to developers. It starts with the simple idea of giving developers access to the power of an AMD ecosystem through the AI coding agents they already use. Whether you're using Cursor, Claude, Codex, Rockom.ai helps those agents understand AMD platforms, understand Rockom, and helps you build and optimize your workloads. In other words, we are making those popular coding agents into Rockom super users. You should be able to describe the workload you want to run, the performance target you want to hit, and then let the agents help you get there. For years, we have been building the open software foundation. Now, we are adding an AI-assisted layer that helps developers use that foundation faster and more effectively. So let me show you what is inside Rockom.ai. It's built on the foundational capabilities of Rockom, our core software stack: runtime, libraries, compilers, tools, framework integration, all of the core software that makes the stack work. On top of that, we built a layer of AI-assisted optimization called Hyperloom. Using Hyperloom, the system can analyze a workload, tune configurations, select and tune kernels, adjust parallelism strategies, and iterate towards performance goals. To give you an example of the power of Hyperloom, I was talking to the lead developer last week. He told me they just pushed through a suite of 14,000 models through Hyperloom, optimizing them and creating valuable insights. This would have been impossible to imagine, even with a large team of engineers before. That's the power of Hyperloom. And finally, we provide an AI-native interface for our developers, AI skills that allow coding agents to understand Rockom natively. I'm incredibly excited by what we have built with Rockom.ai. It's going to profoundly transform the way developers interact with our platforms. So let me make this concrete for you with an example. Imagine you're a developer who wants to optimize Minimax M3 with VLLM on MI355s. Today, there are many things you need to get right. You need the right VLLM optimizations, the right model recipes, the right environment variables. You may need to write new kernels or optimize kernels. And then you still need to tune all of this. With Rockom.ai, this interaction becomes much simpler. So let's see it. You can say, optimize Minimax M3 with Hyperloom. Enter. And behind the scenes, the agent does what an expert would do. Pulls a known good recipe, runs and profiles the workload, it creates and tests a bunch of kernel and runtime configurations, and it keeps iterating towards target. You can actually watch on screen here Rockom.ai write a GPU kernel. It sees an opportunity to write a more optimized MOE group gem. And the result, Rockom.ai delivers a 38% more tokens per second improvement on this specific example. This is the experience we want for developers. Simple to start. That's pretty cool, huh? Simple to start and powerful to optimize. We've continued our relentless focus on performance. With every release, we have delivered significant performance gains. On leading models like DeepSeek, Rockom.ai delivers 3.3 times speed up over ROCm 7. This has been made possible by innovations at every level of the stack. Techniques such as the use of block-scaled fused MOE kernels, KV cache quantization, expert parallelism. But look, the bigger story is how AI agents actually profiled the workload, proposed new kernels, tested configurations, and actually validated all of the results. That exact same focus is also on delivering performance gains for training. On the same hardware, Rockom.ai improves training performance by an average of 2.4 times. Through optimized kernels such as fused flash attention, more efficient checkpointing, and advanced parallelism strategies. Our engineers have done amazing work to unlock the capabilities of MI455 through Rockom.ai. So I'm delighted to share some incredible results on hardware. On running real workloads, we are able to see the system deliver 20 terabytes of memory bandwidth and 20 petaflops of delivered compute. These are the highest demonstrated compute plus memory capabilities of any accelerator platform in the industry today. It's not theoretical, there's measured. Super exciting that we were able to share this on day one. I'm also thrilled to share that the leading AI ecosystem partners who have had their hands on MI455 have had a delightful experience. You can see here what they've had to say. From end-to-end PyTorch testing to ensuring Hugging Face models are getting validated, to VLLM and SGLang running well on MI455, we are incredibly encouraged and excited by what the community is about to unlock with MI455. This matters because day zero readiness is one of the most important objectives we strive for, and that's what Rockom.ai enables. So now let's look at Rockom.ai in action on Helios. This time, we are going to use a codex front end. Let's deploy DeepSeek V4 Pro, a 1.6 trillion parameter frontier model on Helios. Now watch what happens. Rockom.ai pulls the right recipes, it configures the runtime, it implements the model graph onto hardware, and finally serves up the model. There you go. The model is actually up and running. And let's see the model write a simple poem now about advancing AI. Let's hit enter. Isn't that a pretty cool poem? This is the experience we want to give our users. The developers should not have to manually reason through every layer of model architecture, kernel selection, comms strategy, and rack-level deployment. AI is transforming this experience, and that is a very, very big shift for GPU hardware and software. Now, there are few organizations shaping the frontier of AI as much as OpenAI. You heard Lisa and Sachin talk about our partnership. It's been truly wonderful collaborating closely with the OpenAI technical team to make rapid progress with Rockom. To talk about how they are advancing the frontier of software development and our collaboration, I'm delighted to welcome to stage Philippe Tillet from OpenAI. Thank you for joining us here, Philippe. So just so you all know, Philippe is the creator of Triton, one of the most important software innovations in modern AI infrastructure. It's a huge privilege having you here.
Thank you.
OpenAI has always pushed the limits of infrastructure. Can you tell the team a little bit here today as to how your team actually develops GPU software and how have technologies like Triton evolved?
Yeah, for sure. Well, first of all, thanks so much for having me. I was here 2 years ago. It's my great pleasure to be back now. Look, our way of looking at things is there's no one way to fit all applications, and we really try to meet users where they are. So for that reason, we've developed multiple solutions. So for workflows where speed of iterations is more important, we've developed Triton, as you mentioned. So this is typically what researchers will use. But more and more, we've been in a case where we've had to hyper-optimize performance, and Triton didn't give us the level of control that we wanted. So we've developed Gluon for that, which is a lower-level language. And this way, we've been really able to optimize our kernels for AMD, among other things. Our agents have become extremely good at both of them, and we've worked with AMD on both of them as well.
Yeah.
More and more what we're seeing is agents slowly taking over. They're getting just very good, as you just mentioned, at writing this kind of code.
Amazing. So look, I think the work you have done with Triton and now Gluon, right? It's been really, really moving the ball forward for the entire industry. Now, we began our work together with 300 and extended at 350, but now we're collaborating at a different scale with 450 and Helios. So would love to hear your thoughts on how that collaboration has been going and how has that experience been?
Yeah, super well. It feels like ages. I think we started years ago on hardware co-design, when MI450 was in the very early prototyping stages. I think we're able to work really well together, and it's so nice to see the outcome of that and the chip. And more recently, we've been working very, very deeply on software enablement for MI450, both for our models, but also for the broader ecosystem. So a lot of this development has been done open source. We're collaborating on the full stack now, down to the very low level LLVM code generation, so that all the nice hardware advances that came with MI450 can be properly leveraged, in end-to-end applications.
Yeah, and you got your Helios racks, so tell us a little bit about that.
Yeah, it worked. We got the chip, and very quickly, like a single engineer in a few days was able to confirm that everything worked. Obviously,